Lesson 1, angles formed by parallel lines. So parallel lines are two lines that are on the same plane, they're the same distance apart, and they'll never intersect. So two lines that never intersect. They could go on and on forever, and they'll never touch. A transversal is a line that goes through them. So that's transversal. So there's some certain things that happen from parallel lines cut by a transversal, and we use a two-column proof to justify those things. So, example 1, our definition is alternate interior angle. So we're going to use a two-column proof. So set up a T-chart, and on the left side, it's going to say your statement, and the right side is your justification. So why, basically. So our example says we want to find all the alternate interior angles and show them in a two-column proof. So the definition for alternate interior angle says two non-adjacent, which means not beside each other, interior angles on opposite sides of the transversal. So if I take angle 75 here, alternate means on the other side of the transversal. So we're on this side. And interior means on the inside. So we're going to go across on the other side. So angle 75 is the same as angle F. And our reason is alternate interior angles. And we have two angles left on the inside. So inside means between the lines. Exterior would be G, H, A, and B, because they're outside, but we want the inside. So we've already used 75, we've already used F, so alternate from 105 is E. So 105 degrees is equal to angle E. And the reason is alternate interior angles. And that's all our interior angles. So if we were to label this diagram with all the degrees we know written in, F would be 75 degrees and E would be 105 degrees. Example 2, we want to prove the interior angles, and we're going to use same side interior angles to do that. So what that means is if you have two angles on the same side, on the inside, they will add up to 180 degrees. So angle 80 plus angle E is equal to 180 degrees, and our reason is same side interior angles. So we're going to solve for E now. So we're going to subtract 80 from both sides. So E is equal to 100 degrees. We also know that angle D plus angle F is equal to 180 degrees because of same side interior angles. So that identifies all of our same side interior angles. Example 3, we're going to do vertically opposite. I almost said occiput. So vertically occiput, oh my gosh, means that across the vertex of the lines where they cross, they will be equal across. So using our T-chart, we're going to say that 75 degrees is equal to angle B. Justification, vertically opposite. And 105 degrees is equal to angle A. Justification, vertically opposite. So that one's easy. Example 4, we're going to do corresponding angles. So corresponding means it's in the same spot. So if you look at this, as two separate little corners. Angle A is in the same position as E. So if you were to put them on top of each other, angle A equals E. And the reason is corresponding angles. So angle C is equal to angle G, and we'll say CA for corresponding angles. B is the same as H. Corresponding angles is our reason, and D and H. Okay, the last one I definitely did mean to say F. I circled it. Angle B is equal to F. The last one, angle D, is equal to angle H, and that's corresponding angles. So they're in the same position on the other side, on the other line. When you name angles, you're going to take 3 letters, and the middle one is the vertex, so the middle of the angle. So if we're doing angle A, our vertex is B. So we're drawing an angle here. So you go from all these points. Start at E. Go to B. Then you go to I. So angle A is equal to angle EBI. It could also go the other way. So start at I, go to B, then go to E. So IBE. Either is right as long as B is in the middle. So for this angle here, angle B, we start at J, we go to I, then we go to K. So JIK, it could also be the other way, KIJ. So this way. So that's how you name an angle. Example 6, we want to find angle A, angle B, and angle C, and angle D. It's supposed to be right here. So what we're going to do is we're just going to work in steps. So let's find angle A first. A is in the same position as 110 degrees. So we know that angle A equals 110 degrees, and our reason is corresponding angles. So they're in corresponding locations. So there's our first step. We can also see that A is vertically opposite from angle B. So that means angle B is equal to 110 degrees. And the reason is because they are vertically opposite. If you look at the diagram in a little bit different of a way, so I'm going to flip it so you can see it. So if you look at it like this, we know that this is 110 degrees and this is 110 degrees. Obviously you can't flip this on your page, but you can flip your page around to see it. Angle C and angle A are on the same side and on the inside. So they're same side interior angles. And what we know about that is they equal 180 degrees. So angle C plus A, which is 110 degrees, equals 180. Solve for C, we subtract 110 from both sides, and angle C is equal to 70 degrees. And the last thing that we want to find is angle D. Now angle D and angle C are in the same spot, so they are corresponding angles. So that means they're equal. So angle C is equal to angle D, and angle C is 70 degrees, so that means angle D is also 70 degrees. So that is solved. We found all of our missing angles.